By the fundamental theorem of algebra, any polynomial with real coefficients is going to factor either in quadratics that are irreducible or linear factors. So we've already talked about the example of a polynomial factoring in linear factors, and we've also discussed what happens when those linear factors occur with multiplicity. Now let's discuss what happens when you can't break down into linear factors and you are left with a quadratic. So let's take our integrand, minus 2x plus 4, over x squared plus 1 and x minus 1 squared. And our first thing that we should do, as always, is try to factor that denominator as much as possible. But this denominator is already factored as much as possible. Here, the linear factor x minus 1 is occurring twice. And this, even though it's a quadratic x squared plus 1, it is not going to break down further. The x squared plus 1 parabola does not touch your x-axis. It doesn't have any real zeros. So it is irreducible. And for that reason, we are going to give this factor, x squared plus 1. Because it's an irreducible quadratic, we give it a straight line or a monomial on top, ax plus b, right? Some unknown straight line. Now, the x minus 1 is a linear factor, so it's just going to get a constant up top. But because of the multiplicity, it gets two fractions. So this is going to provide us the partial fraction decomposition that will allow us to solve this integral. So let's figure out what a, b, c, and d have to be. We will take the ax plus b and multiply it by the x minus 1 squared, because that's the only thing it's missing. It already has the x squared plus 1. It's only missing the x minus 1 squared. We will take the c and multiply by x squared plus 1 and 1 extra x minus 1. That will give it the correct denominator. And we'll take the d and multiply by x squared plus 1. Now, that's just the numerator, and I know that that numerator has to be equal to minus 2x plus 4. So we get a system of 4 different equations. By matching up terms, actually, let's go ahead and expand this numerator first. After we multiply everything through, you should end up with ax cubed minus 2ax squared plus ax plus bx squared minus 2bx plus b plus cx squared minus cx. Oh, sorry, that should be plus cx cubed. Plus cx cubed minus cx squared plus cx minus c plus dx squared plus d. All right, now looking at how many x cubes we have 0 x cubes, which are equal to the a's plus the c's. We have 0 x squareds, which are equal to the minus 2a's, the plus b's, the minus c, and the plus d. We have minus 2x's, which is equal to an a minus 2b plus c. And finally, we have our constants, of which we have 4, equaling a b, a minus c, and a plus d. So you have a system of 4 equations here. I'm going to trust that you can pause the video and solve this system correctly. We have a as 2, b as 1, c as minus 2, and d as 1. So using this integral becomes the integral of ax plus b, so 2x plus 1 over x squared plus 1. And we have plus a c, but c is minus 2. So it'll be minus integral of c over x minus 1 and plus integral of d, which d is equal to 1. So 1 over x minus 1 squared. So our first integral is a u substitution. Actually, hold on, before we even do that, I need to break this first integral up as integral 2x over x squared plus 1, and then plus a 1 over x squared plus 1. And then we'll still have our other integrals. All right, now the first integral will anti-differentiate as a u substitution. This becomes natural log absolute value x squared plus 1. Now our second integral is a trigonometric substitution, that's tangent. Our third integral is just a trivial u substitution. It anti-differentiates as a natural log absolute value x minus 1. And we have another trivial u substitution in our fourth integral. This will anti-differentiate as a minus 1 over x minus 1. So another partial fraction decomposition. If you have multiplicity, you have a new fraction for every multiplicity. That's where we got the c and the d from. And if you have an irreducible quadratic factor, like this x squared plus 1, just make sure you give it a linear factor on top of it.